Welcome to This Explainer. Today, we are diving headfirst into something truly wild. We're unpacking a fascinating paper that presents what's called the Nexus framework. It essentially attempts to operationalize four of the most notoriously unsolvable math puzzles out there, the Millennium Prize problems, by viewing the universe itself as a recursively executing computational system. Let's look at how this pure domain architecture completely recasts the foundations of reality.
Here's our roadmap for this journey. We'll start with the Typeless Universe philosophy, then hit the UATS 7-tuple framework, explore Riemann as runtime safety, look at Navier-Stokes constraints, dive into Yang-Mills recursion depth, and wrap up with P versus NP.
All right, part 1, the Typeless Universe philosophy, and this radical idea of an ontological inversion.
To really grasp the Nexus framework, you've got to throw out the classic idea of the universe as just some empty box filled with stuff. The core argument here? There is no pre-existing void, period. Instead, the boundary itself, what they call the absolute unoccupiable seam, is the singular primary invariant structure. Everything else we observe, from discrete states to numbers to linear time itself, is just a secondary, trailing projection read from orthogonal axes.
Think about it. Our classical intuition assumes static objects floating around in an empty void governed by external laws, right? Well, Nexus calls that a massive ontological error. It argues instead for a perfectly filled topological frame. There are literally no empty storage slots and no sequential before and after. Existence isn't passive. It's an intensely active, computationally forced geometric frame that simply has to maintain its structural stability across every single scale.
Moving on to Section 2, the UATS 7-tuple framework, or the universe's grammar.
So if the universe isn't relying on external laws, how does it actually run? The framework introduces a strict underlying grammar known as the Universal Action Type System, or UATS. It's built on a 7-tuple structure with some really intuitive groupings. You've got R for the repeater, or fold machinery, that handles symmetry, kernel, and scale base. G is the gap or query, essentially acting as the aperture. And B is the rendered split, which deals with exhaust, residue, and closure. Basically, the universe is an active system chained to these strict operational rules just to keep from falling apart.
Which brings us to Section 3, Riemann as runtime safety, a very literal cosmological bug check.
Now this is where it gets really cool. The framework takes the notoriously difficult Riemann hypothesis and completely flips it. It's no longer just an abstract existential math puzzle about prime numbers. It becomes a matter of runtime safety. In a computationally forced universe, any illegal off-seam zeros in the prime stream would literally represent dangerous, highly unstable structural states in reality's coupled arithmetic analytic substrate. Riemann is essentially the universe running its ultimate cosmological bug check. To actually formalize this, the authors construct a specific two-fiber Hilbert bundle operator. And the goal here shifts dramatically. Instead of trying to prove some vague existential property, the target is a quantitative operator inequality, specifically proving that the kernel of I plus L equals exactly 0. By proving this contraction property, the framework mathematically guarantees there are absolutely no off-seam zeros. It's sheer thermodynamic constraint, forcing perfect system stability. Next up, Section 4, Navier-Stokes substrate constraints. Let's decompile fluid dynamics.
Here, the paper translates classical, continuous math into raw, discrete operational logic. You know how classical Navier-Stokes equations worry about smooth fluid vectors developing infinitely dense singularities? Well, Nexus just strips away the continuous notation entirely. Continuous transport becomes a discrete transport advection primitive. Nonlinear flow turns into a localized gate routing operation, meaning the flow is actively dictating its own continuing path.
This leads right into what the text calls lock number 5, a simple common field. When you map the leak operational primitive to transport, it exposes continuous Navier-Stokes equations as just macroscopic approximations. Why? Because they are hard-capped by a minimum addressable physical scale, the Planck fluid length. You literally cannot have an infinite density singularity because the universe has a strict discrete pixel limit at the Planck scale. The substrate simply will not allow it to happen.
All right, Part 5, Yang-Mills and recursion depth, the compile requirement.
In standard physics, the Yang-Mills mass gap is what explains why certain particles have mass when classical theories say they shouldn't. But Nexus reframes this as a compile depth requirement. In this view, the mass gap isn't some physical object you can hold in your hand, it's a strict system requirement for geometric persistence. It is the precise minimum recursion depth that a loop has to achieve to successfully phase lock and actually exist in reality.
Think about the instanton action, which is tied to the strong coupling energy scale. It marks an exact computational transition point. If the system drops below a critical depth ratio, the underlying sink operator starts destroying physical coherence way faster than the leak operator can rebuild it. This strictly outlaws the existence of massless glue balls, and it neatly explains the mass gap entirely through operational recursion limits. Pretty elegant, right?
Finally, Section 6, P versus NP, and limits. Viewing complexity as an artifact.
Classically, P versus NP asks if problems whose solutions are easily verified can also be easily solved, assuming some intrinsic combinatorial hardness. But applying the Nexus ontological inversion, we get a totally different answer. The framework argues that complexity is not an intrinsic property of the problem at all, not even close. It's merely an observational artifact of our viewing frame. Complexity is entirely frame-dependent. This leads us to the universal interface angle hypothesis. The idea is wild. If you take an incredibly hard exponential time NP problem and mathematically rotate it to align with this universal interface angle, that nasty exponential time viewing plane is completely replaced by a much simpler polynomial time geometric projection. It's literally all about finding the exact right mathematical angle to view the data.
So what actually drives this rotation? That's where collapse signature theory comes in. The physical act of wave function collapse serves as the literal mechanism that translates a horizontally distributed superposition into a vertically driven deterministic execution. Energy safely collapses through these twin prime gates into a highly structured polynomial solution. It's the universe actively forcing the fold.
Now, hold on a second. Let's slow down to preserve our scientific integrity here. The authors of the Nexus framework are totally transparent about their current limitations. As compelling as the P versus NP interface angle is, the paper openly concedes it still lacks a comprehensive combinatorial proof linking those discrete states back to continuous projections. Plus, the sheer mathematical beasts that are the Hodge conjecture and the Burchin-Swinnerton-Dyer conjecture, they are fiercely resisting translation into this universal exhaust residue matrix. So, there are definitely some massive unconquered frontiers remaining.
Which leaves us with a truly profound question to ponder. Are prime numbers, fluid turbulence, and quantum mass just independent random artifacts of nature? Or are they the inevitable, geometrically forced readouts of a single, unbounded, recursively executing reality? It's a perspective that absolutely forces you to look at reality not as a collection of things, but as one continuous, unified computation. Thank you so much for tuning in to this explainer. I really hope this deep dive into the Nexus framework has sparked your curiosity to explore these fundamental mysteries even further.